Hi. So I'm assuming you've read Quinn's essay and you're ready to talk about these words. Let's start with postulate. What's that? Tick, tick, tick. I know you've read it. Okay, this is a video. She says it's a basic, self-evident proposition we accept as true until proven otherwise. It's an assumption, a belief. Wait, how is it different from a belief? Well, if data doesn't back it up, the postulate has to go. It does have to match what we observe. Okay, so that's a postulate. What did she say was the basic postulate of science? This is a biggie, guys. There exist fundamental laws of science that are universal and immutable. Universal? That means it works everywhere, absolutely everywhere. Immutable? Well, that means always. All times past, present, and future. This is a really important postulate. Think about it. Scientists believe in an orderly universe governed by consistent rules. We may not know all the rules yet, but they are out there for us to figure out. That rules out inconsistent stuff like magic. I think it was Arthur C. Clarke who said something about magic just being science we don't yet understand. What I learned today will still be good tomorrow and can be used to figure out yesterday. What I learned today can be tested by observation, experiment, and logic. What I learned today may have to be modified by new insights from testing and experiment. It must stand up to testing, hard-hearted testing. We should be able to confirm or verify the theory, but confirmations should only count if they're the result of risky predictions. Every genuine test of a theory is an attempt to falsify it. Confirming evidence should not count except when it's the result of a genuine test. And this means that it can be presented as a serious but unsuccessful attempt to falsify the theory. Model. Model. It's not like your car. A set of statements. Okay, mathematical, often mathematical, that tries to explain the how or why of something. These aren't as well established as theories. There might be more than one that could explain something. And that brings us to theory. Theories are more than models. They're known really well. A model that has stood test after test after test eventually can be thought of as a theory. It's a pretty solid thing. It's a complex construct of ideas and math that summarizes what we know about something. Science laws are different than societal laws. How? A student once characterized it this way. If I break a societal law, I get in trouble. I might go to jail. If I break a scientific law, the law gets in trouble, and I might get a Nobel Prize. I thought that was pretty fun. Another student said, and I don't know if he was paraphrasing another source, but he said, societal laws proscribe behavior. Scientific laws describe behavior. Whatever. Science laws and society laws are different sorts of things. And a theory is on the way to being a law, isn't it? The principal criterion is that it be falsifiable, that you can show it's not true, that you can test and try to show that it isn't true. Scientific knowledge is not based on an appeal to authority. Despite how science teachers sound at times, it will never be because Newton said so. Scientific knowledge is always provisional. It may have to change. For a long time, Newton's laws ruled. And then Einstein came along. Newton's laws were incomplete. Not invalid, just not complete. Einstein improved the model theory, and possibly his is incomplete and will be improved by someone else. Scientific knowledge advances by discovery. Let's see here. Let's imagine an example. After your birthday party, you take your birthday balloon and you put it in the freezer. When you come back, the balloon has shrunk. You've made this observation, and you're wondering about it. The volume of the gas in the balloon decreased when it was cold. You might speculate that there's some relationship between the volume and temperature. You might even guess a mathematical relationship. Then you set up an experiment where you measure the volume of the balloon at a bunch of different temperatures while carefully holding everything else constant. Okay. It does appear that the volume decreases with decreasing temperature. Maybe your data doesn't follow the mathematical rule that you thought it would. You graph the data and try again. Imagine an improved testing arrangement and maybe begin thinking outside the balloon. Okay, sometimes the correction process is slower than it should be. Good experiments are difficult to devise and to implement. Oh yeah, human nature can get in the way. The known is so much more comfortable than the unknown. And egos. Egos too. Scientists have them. They can get in the way. And, religion can get in the way. Religion is based on untestable faith. Oh my gosh, politics too can get in the way.